Hello everyone, welcome back to my channel. So in today's tutorial, I am going to discuss about the comparison between BJT and JFET. So these two figures are of BJT. This is NPN BJT. Here the arrow is directed towards the emitter. By this we can understand that it is NPN BJT because in NPN BJT the current will flow from the base to the emitter. But this is PNP because the arrow is directed towards the base terminal and the current will flow from the emitter to the base. Now these two figures are of JFET. This is N channel JFET and this is P channel JFET. In N channel JFET, the current will flow from the gate to the source terminal. For this, the arrow is directed towards the source terminal. But for P-channel JFET, the current will flow from the source to the gate terminal. That's why the arrow is directed towards the gate terminal. Now here is the difference between BJT and JFET. These two figures are of BJT. This is NPN and this is PNP. And these two are of JFET. This is N-channel JFET and this is P-channel JFET. Now, the input current and the output current. For BJT, the input current is the base current IB and the output current is the collector current IC. But for JFET, the input current is the gate current IG and the output current is the drain current ID. Now in BJT, the input voltage is the base to emitter voltage VBE and the output voltage is the collector to emitter voltage VCE. For JFET, the input voltage is the gate to source voltage VGS. The relationship of input and output. For BJT, the collector current IC is a function of base current IB and it is IC equals beta IB. Here beta is a constant. So if we change the value of IB, then only the value of IC will get changed. So here IB is the control variable. But for JFET, the ID is a function of voltage VGS and ID equals IDSS multiplied 1 minus VGS upon VP whole square. Here IDSS and VP are constant. So the only control variable is VGS. If we change the value of VGS, then the value of ID will also be changed. Now control device. The BJT is a current control device because the output current IC is controlled by the input current IB. But JFET is a voltage control device because the input voltage VGS controls the current flow. Polarity. The BJT is a bipolar device because both holes and electrons, that is, majority and minority carriers, are responsible for current flow. But in JFET, it is a unipolar device because either electron or hole, that is, only majority carrier, is responsible for current flow. The current, the base current IB in BJT is very small. So IC is almost equal to IE, emitter current. But in JFET, the gate current IC is small. So IB is almost equal to IS. For BJT, the voltage VPE is 0.7 volt. But for JFET, VGS is always reversed. So IG is always 0. Linearity. BJT is a linear device because IC equals beta IB. Here no square or cube or any other term is used. So it is a linear device. But for JFET, here it is a square term. So it is a non-linear device. Power consumption. In BJT, the power consumption is high. But for JFET, the power consumption is low. Input impedance and output impedance. For BJT, the input impedance is about 1 kilo ohm to 3 kilo ohm. It is very low. But output impedance is high due to higher gain. But for JFET, the input impedance is very high, but output impedance is low due to lower gain. Thermal stability. In BJT, it has bad thermal stability, but JFET has good thermal stability. Gain. The BJT has high voltage gain but low current gain, but JFET has low voltage gain but high current gain. Sensitivity. The sensitivity of BJT is low, but the sensitivity of JFET is high. Now, BJT noise. The noise of BJT is high, but the noise of JFET is low. Size size of BJT is larger, not perfect for IC, but the size of JFET is smaller, so it can be easily used as IC. Application. BJT is preferred in low current applications, but JFET is preferred in low voltage applications. Frequency. The frequency changes of BJT will affect its performance, but for JFET its frequency response is high. Cost. The cost of BJT is low, but JFETs are expensive. Offset voltage. BJT has offset voltage, but JFET doesn't have offset voltage. Now, what is offset voltage? It is the input offset voltage is the differential DC voltage that should be applied between the inputs of in order to make the output zero. Now the terminals. For BJT as compared with the emitter terminal, both the terminals of BJT like base and collector are more positive. But for JFET, its drain terminal is positive and the gate terminal is negative as compared with the source. Now BJT switching. The switching time of BJT is medium, but for JFET, the switching time of JFET is fast. Biasing. BJT biasing is simple, but biasing of FET is difficult. Temperature coefficient. BJT have a negative temperature coefficient, but JFET have a positive temperature coefficient. So thank you so much for watching my video. If you like my video, then please press the like button and subscribe my channel. Thank you very much.